So in this video, let's tackle the final message type called the correlation. So let's get into that. The chart that is used to plot correlation or show correlation is scatter plot. In other words, the scary plot. For many people that I've discussed with, especially the business types, they are scared of the scatter plot. And I don't understand why. Yes, there are a lot of jargons associated with scatter plots. So in this video, let's go through them and try to demystify them. So first, let's start with the definition of what correlation is, right? Because many a times we tend to use terms without understanding things really well. So let's look at the first definition that Google throws up. A mutual relationship between two or more things. So we are talking about a relationship. That's not really very useful for our purposes, right? But the example actually is a very nice illustrative example for us. The research showed a clear correlation between recession and levels of property crime. Basically, so they are trying to measure recession using some variables, and then they are trying to correlate to levels of property crime to see whether there is a relation. That means when one is moving up, is the other one moving up, right? And then if you go to the first definition down, you could see this. It says this indicates the extent to which two or more variables fluctuate together. That means when one is moving, the other one is also moving. This is positive correlation. When one is going up, the other is going down. That means it's a negative correlation. That's what this definition says. So in other words, we are talking about the relationship in terms of, are they moving together or are they moving in opposite direction? Is there some predictability to the relationship? That's what we are interested in. So now let's quickly revise what we have seen in 5 key messages so far in charts. So we started off with the first 3 and they are fairly simple. And then the last 2 are statistically oriented. In distribution, if you remember, the keyword was spread versus concentration or frequency. So there we were interested in range or variance, right? So the idea was distribution is about how does a single number change on its own axis. So we took a green ruler of a single number and we tried to plot either the frequency bands, which leads to histogram, or we plot every data point on the whole axis, which gives us rise to this box plot or circle plot, right? So that is about a single number. Now, when it comes to correlation, the message is how do two numbers relate to each other? That's the key distinction. So there is, so in the first case, distribution, it's a single number on its own axis. Here, two numbers, they are relating to each other. So the keywords that are used here, like for example, profit increases or decreases with, for example, sales, or is it caused or affected by? In this case, we are going beyond correlation. We are talking about a causation relationship. For example, if I increase my marketing expenditure, will it result in my sales volume increasing, right? For example, if the temperature increases, does the ice cream sales increase, right? So these are the things that we want to understand. So if you see all these 5 key messages, the first 3, we were focused on taking a number and then summarizing it across some dimension. For example, if we take something like joining trend, right? Joining count of employees. In ranking, we want to look at which departments have what, and in trend, we are looking at a time-wise comparison. In terms of composition, rather than looking at the number on its own, we are looking at a percentage of this as a whole, right? So in all of the first 3, the overall picture of the number was defined by the buckets, by the dimensions in play. Whereas in the last 2, we are tackling these numbers on their own. In distribution, a number is on its own axis. In correlation, 2 numbers are on their own axis. We can of course use dimensions to break it down or summarize, but then this is the difference between the last 2 and the first 3. Now let's cover some theory now. The question that I want you to consider is, why are scatter plots scary? Many people say it is scary, right? So maybe because of the statistical jargons that are thrown at them. But to me, I want to give you a very nice visualization of a scatter plot. If you remember, when we wanted to visualize measure, I took you to our school days or your school days and then asked you to visualize the rulers that we have used, right? So the pencil and the ruler. So what did we use these two things for? We used it to plot, isn't it? The chart paper, the XY plots that we have used. This is all Scatterplot is. All we are doing is what the work that we have done in school, now we are doing it on Tableau or some other tool, right? So we are taking an X and Y axis and we are plotting each point as we get it. What we plot on is determined by the report that we have, and then we plot this. Then when we are plotting, we want to, for example, see as X is increasing, is Y is increasing. These are the kind of questions that we want to answer through scatter plots also. So when you think of scatter plot, just go back to your own memory of your chart paper that we have used and the XY plot that we have constructed. So let's start with a cozy example, especially given that we talked about school. So here is ice cream sales versus temperature. Some data that I found from a website, which I'll show it to you. So here is temperature on different days, and then what is the ice cream sales on those days, right? So when we look at this kind of a data, it does not help us to understand what's going on. So let's plot them on a XY thing. So here temperature is on the X-axis, sales is on the Y-axis, because we are interested in seeing as temperatures go up, does the sales go up, right? So that's how we determine X and Y, but flipping it is not a major crime. Yeah, but this is fine. So now this is telling us, yes, it does seem to be, there does seem to be some relationship going on between the two. So let's draw a line through them. Now this makes it clear, yes, as the temperature increases, the sales increases, not in a line like an exact trend like this, but the points are lying next to each other. So there seems to be a, an increasing relationship. That means on days that we have low temperature, we don't have that much ice cream sales. On the days when it is hot, we consume more ice cream. So this is something that we all understand. So this chart makes absolute sense for us, right? So let's get away from ice creams and school chart papers. Let's get serious and then talk about some business examples. The typical thing that is used for scatter plot is sales versus profit. For example, the whole purpose of running a company, especially for the business owner, is to earn more profit. So people assume that if you increase or if you get more sales, you will get more profit, or the biggest customers who give us the biggest sales are also giving us the biggest profit. These are the assumptions that we normally assume. So in a scatter plot, we can plot a sales and profit and then see whether these assumptions are true. So this is one very good use of scatter plot. The second thing is, for example, when we increase marketing expenditure, right? So in the form of promotions, in the form of campaigns and many things that companies do, does it actually increase in sales, right? So this is one question. And even a further deeper question is, so does the increase in marketing expenditure actually result in a proportionate or even more increase in sales, so that we are actually, the profit is not going down? Meaning we could look at marketing expenditure versus profit and see, as we increase marketing expenditure, actually are we getting more profit even, right? So which is one more level, right? So marketing expense affects sales then affects profit. So we have a lot of possibilities. So it is a very good chart, and you are not really limited by just these two examples, but these two are, I would call, ambassadors of the scatter plot. So now let me ask then, why are scatter plots scary, right? So far we have looked at an exciting ice cream example, we have looked at sales and profit and marketing expenditures, campaigns, all nice and rosy stuff. So why are scatter plots scary? So let me scare you now. So jargons are dragons. 1, 2, 3, 4, 5, 6, 7. Okay, let me stop here. So before these dragons, swallow you. So these are all the terms that are associated with scatter plots, right? So that's the reason people actually find this to be difficult. I remember when I was in business school taking statistics classes, fortunately the professor, we got two professors actually. So the first professor was very intelligent and he scared the hell out of everyone by explaining all of these things in statistical jargons. And I remember the second professor, who was supposed to start off with linear regression, which is considered to be an advanced topic, and then move on to further complex items. He gave such beautiful examples of what's going on that even the guys who are not really mathematically inclined or statistically oriented, they all loved the class, and he got the best professor award. I remember this professor started the class saying, is there a relationship between the number of toilets built in the US and the unemployment rate? And the data shows there is. This is how he started, right? So what is this telling? This is telling we could actually look at two variables moving together, number of toilets and unemployment rate. They move together. If you see the data, it exactly looks like. But then it does not mean one causes the other. So there is a difference between something is correlated, there seems to be a relationship, versus what is actually causing versus one versus another. This is called the spurious correlation. Anyway, just enough stories. Just wanted to tell you there is nothing to be really scared about. What you really need to understand is positive or negative correlation. Positive is, for example, if I increase my sales, does my profit go up? When one goes up, the other one also goes up. This is positive. Negative is when one goes up, the other one comes down. So I'm going to give you a site which will give you a good explanation of all of this. So from a correlation perspective, that's all. High versus low. High means this is what we think there is a correlation. Low means it's not really, it is there, but it's not really worth enough. So, and all of these next few terms, linear regression, line of best fit, trend line, they all mean basically this drawing a line through these the points, so that we could actually see some line of best fit. That kind of, there are some mathematical constructs around how this line is constructed and or derived. You don't have to worry about. Linear is telling you there is a line. That's all. Line plus AR is linear, right? So just linear means there is a line, right? So we think that as temperatures go up, sales will go up like in a straight line fashion, right? So, but in reality, in real life, sometimes things go up till a point and then they drop and then they go up again. There can be these waves, there can be, other kind of shapes. These are called non-linear, meaning they are not lines. They are not a single line. So whenever you see this word linear, cut off that AR and remember line, right? So all we are doing is just drawing a line through this. That is also called a trend line. So that quickly tells us, is there an increasing trend, rather than our eyes trying to gravitate, and then forming a picture through looking at these different points. The line helps us to quickly orient and get a sense. That's all line is. And then there is interpolation and extrapolation, and that means interpolation means we already have data for the things and then we are trying to predict. So these two terms really comes from predictive analytics. So linear regression is the first thing that people use when we are trying to predict. So for example, tomorrow if the temperature is going to be 21 degree, right? So can I predict my ice cream sales? In this case, we have data from 12 to up to 26. So the data is within what we have. The prediction, what we want to do is within the data that we have. So this is called interpolation. Whereas if I want to predict what would be the ice cream sales at 30 degree, so then we do not have data and then we are extending the line, right? So where we are extrapolating. But these are terms these are scary terms, but really these concepts are very useful. These are the things that I see my business owner clients, they're very interested. These are the things that they talk very often. They may not be using these terms, but this is what people want to do, So don't let these terms scare you away. Outliers is telling, so when I draw this line, is there some point that's way off? For example, on one day, if I see at the 20 degrees Celsius, I have really low sales. Or at 20 degrees or 26 degrees, I have like absolutely high sales. These don't seem to fit the pattern. So that's what outlier really means. Again, there are mathematical ways to define an outline, but the general thing is, if you see, if there is some point really standing all apart, that's an outlier. So you can remove the outliers, because many a times outliers distort what we are trying to do. and then you could have for example, let's say on one of the days there was an extreme heat wave. On that day the ice cream sales could have gone through the roof, right? So we don't really want to consider that to really define the line, so which could distort the line itself, right? Because when we take averages, it could get affected. The outliers, the big values, really huge values, will affect our averages. So from those senses, outliers are the things that we want to avoid. So just summarizing all the theory, so if you just look at this ice cream sales picture with this line drawn through it, you got the understanding of scatter plot. That's all you need to know. So now I want to leave you with two great online resources. One is a site called Math is Fun, from where I picked up this ice cream example. And then the second beautiful source is Khan Academy. This is for 8th grade math. So let me take you there. So here is the first item. So I would recommend that you just read through this. This is a very nice it gives all the different examples. Whatever I explained to you so far, they are all there. And then there is even a section on correlation, what different correlations will look like, and there is even a separate page on correlation itself. Yeah, you don't have to worry about the technical aspects, but what I like about this site is very nice examples, something that all of us can easily relate to. Yeah. And then when it comes to this Khan Academy, so the nice thing is they have scores of videos on scatter plots, right? So here is a video which gives you different charts and asking you to predict what kind of a relationship is there. And then if I go to the next video, so here there are 4 or 5 if I just maximize this, there are 4 or 5 different charts. They are asking you based on the description, linear association, which chart is describing that, right? And then I could go to the next one, which talks about outliers in scatter plot. And then the next one, there are clusters. Clusters is not something I'm going to cover now, but this is a feature that is available in Tableau, and this is considered to be an advanced thing. But just read through this. These are things that we can very easily understand. The nice thing is this is for 8th graders, right? So for all of us, this should be something that we should be able to relate to. And then there are even quizzes that allow you to test. I in fact ask some of my clients, the students from some of my clients, to go and take these Khan Academy things to just go and refresh the basics and then come back to Tableau. And what I found is they find this now scatter plots are not scary anymore. It makes absolute sense, right? So these are the two resources that I would recommend for you. Have fun with them. Now let's get back into Tableau. So here is the ice cream sales data set. So I have brought it into Tableau. So you could see there is ice cream sales and temperature. So as we know, so all we need to do is just double click. So let's double click. So we want first temperature. So it is going across, and then we want to put ice cream sales. So it is ice cream sales has come here, temperature has come here. We want the other way around. So temperature is on the x-axis, ice cream sales is on the y-axis. But what's surprising is in the chart that we have seen there were a lot of data points, and then there's only one data point. Whereas if I see the view data, there is a lot of data points. What's really happening? I mean, this is something not a big question. I mean, there is aggregation going on. So what Tableau is doing, taking all these values and then summing them up. So all of the ice cream sales, they are summed up into one number total. All of the temperatures, they are summed up into one number, because that's what by default Tableau does, right? But in our case, we do not want any of these aggregations to happen. We just want all the values. In that case, we can go here and then say, basically disable this disaggregate aggregate measures. Then now this will give us all the data points. Now we can see this, right? So this is very simple. So in fact, so I can enable this drop lines. Now you would be able to see where these coordinates are. So now this is plotted to 22.6 versus 445. And then now we can see this is 406. These drop lines are a nice feature to check. We can turn on the labels. It will give you one of these things. We can even put, for example, both temperature as well as ice cream sales on the label, and then we can edit this to have the typical brackets kind of a thing that we are used to seeing in our school days, just to refresh our memory. So this kind of a thing, and we can apply. So now we can see each of these things, how this is working. Anyway, this is something just to show you. The best is to turn it off. So now we got a scatter plot that plots everything. The nice thing about this scatter plot is, apart from this x and y axis, you have a number of other possibilities to configure these marks, right? So you have color, we have size, we have shape. So, and then anything which is beyond that, we can also put detail, right? So if you have dimensions with a limited set of values, maximum I would recommend 5 to 7, put them on color or size or shape, right? And then you can put other things on the detail, right? So really, so let's get into the more practical example, which is the sales versus profit in a superstore. So let's click on sales, let's click on profit. So let's check where things are. So sales is here and profit is here. We want it the other way. As sales increases, we want to see whether profit increases. As usual, so there is only one data point. So here one option we have is to disaggregate. In that case, we will see around 9,900 marks. This is not what we want, so let me go back. But now let's drop things at a different level. For example, if I drop category and subcategory, now you could see there are 17 points which are plotted. So how are these 17 points that are arrived at? So one way to look at this is go to analysis, view data. You would see what data is coming in. So the thing about Tableau that you need to keep in mind is any chart that is produced, a step before that is a report is produced. This job of producing the report is done by the database. Tableau constructs a query and then sends it to the database, gets this report, then it works on visualizing the report. So on complex things, I always recommend you should go to view data and understand what's going on. An easier way to even get that data is to right click and then duplicate as a cross tab. All we are doing in this scatter plot is to try to visualize this. That's all we are doing, right? So now let me, for example, drag these things out, put something like, for example, customer name. In this case, if I do a duplicate as a cross tab, all we are doing is customer wise profit and sales. That's what this is showing. Now, since customers are all in the same thing, so let me put them by, for example, segment, I can put it on color, right? And which state they are coming, I can put that also. So not really limited to what we could do. So we have a number of possibilities. We could drill into any one of them. Now we can see where is this customer coming from, for example, corporate customers, what is the trend, and home office and all that, right? So before I go there, so the other thing, how do we create this line? All you need to do is right click, show trend line. This will show you one line. And you can hover over this to understand the equation, but for most of us this is not a great thing, and there are some statistical stuff associated with this which you can always look up and read in the manual. So when you add a segment, when you already have a trend line, so you something on a color, so you will get one color per line, and then you would be able to see each of these things. Also you have options to configure this trend line, edit trend line, so you have number of options which you can look at. So that's all with respect to scatter plot. You could actually in theory plot a lot more items here. So in essence, it's a very simple thing to get a relationship between two numbers, and then we draw a line through this to see whether there is actually a trend going on, some sort of a correlation that we can get a sense of. That's all.